So I think one of the most exciting things has been people trying to steer away from just chat APIs. So community has been overfitting to.
If you hadn't studied AI or machine learning and you were interested in it, what advice would you give? Here's Xavier. Thanks for joining us. Today we're going to talk about generative AI. So anything you wanted to bring up?
I think generative AI right now, has been really exploding recently, both in terms of like products available to users, but also open source contributions. And I'm really excited to see kind of where it'll all like develop, kind of interesting applications people create.
Yeah, I am also excited to see any applications that you've seen that have sparked your interest.
Yeah, so I think one of the most exciting things has been people trying to steer away from just chat APIs. So obviously, like things like ChatGPT and other assistants were the most popular ones, but now people are beginning to really integrate these models into different mediums. So, for example, like Replit is now injecting large language models into IDEs. Or you might imagine like assistants that have more control over, say, your phone. Like maybe they can access your like different apps. Finding different ways of exposing these like models, I think could really empower users.
Okay, so let's first talk. I actually haven't heard of this one for the IDE, an integrated development environment, which is basically what software engineers use. So, yeah, so you're saying beyond so I guess GitHub Copilot's been out for a while, and that's already using large language models to basically give you a nice autocomplete. So what's going on with this one?
Right, yeah. So I think.
And what was the name of it again?
So Replit, that's like a startup currently. I think there's a few players in the space, but I think Replit is just the one that comes to mind first. So I think what's like thinking about Copilot, right? Copilot is sort of like at a high level, it's just like next token prediction, right? It just kind of does autocomplete and helps you write functions. But you can imagine that there could be better integrations into an IDE. Things like have it be part of like the tools that you can use for an IDE. You might allow it to highlight text and have it explain things to you. Or you might be able to like highlight text and like translate it into some other language, or do all sorts of things that go beyond just text completion.
Right. So basically just like a helper that maybe it saves you a step instead of like Googling or using a search engine to like find an answer online. Maybe it just helps you right off the bat.
Right, but more than that. So more than just like a chat API. Like ideally, you wouldn't have to just copy your code and paste it somewhere, right? Or just like you could actually do things beyond like, let's say, text highlighting and having actually like explain to you what this is, right? Could be interesting. Like have access to more tools than just what you have available, or even things like, for example, having access to the whole code base, being able to retrieve other files. And this could be in some cases critical where like your code cannot really depend on something like Copilot. Like you don't want to send your code to some server online, for example. Ideally, you might want to have something locally, or you have some sort of promise that like your data is not being shared with other people.
Right. I would assume that we would have to be sending the data through to an API. Even with these newer models.
Sure. But like, for example, I believe one of the more recent versions of ChatGPT now offers some like privacy with whatever data you send to them. Like they won't use it for training or things like that. And so I think having some of these things be more explicitly laid out could also help beyond just like, pass it through some black box API and see what happens.
Yeah, it could be pretty annoying if your private code is actually being used and exposed to other people. That's intellectual property.
I recall there was a recent issue with like I believe it was Samsung or some company's employees were actually sending their code, their private code, to I think it was ChatGPT, and of course like that's
Okay, but suppose we factor out this privacy issue. You think something like this will offer a lot more benefit than just like say GitHub Copilot?
I think it could. It just depends how creative we get. I think in general the community has been overfitting to chat APIs. And I think, and don't get me wrong, I think chat APIs are fantastic. I think they're a really natural way to expose users to these models, but I think they're also sort of like limiting. So, you're not going to ask ChatGPT how to cure cancer, and it will do it for you, right? It just doesn't make sense. It's not something that you formulate as a interaction. So having different APIs that allows us to tackle that problem somehow, I think it's required if we are to solve these problems using, say, these large language models.
Cure cancer, that's ambitious.
I mean, sure. I mean, we could say, solve the Riemann hypothesis, or any kind of large scale problem that requires more than just a single discussion or conversation.
Right. The Riemann hypothesis, for those of you who don't know, is $1 million open problem in math, which is probably the most famous one, or infamous one, actually. It's been open for about 150 years. Yeah, I mean, of course, the path to solving these more interesting questions is, it feels like we're actually quite far from this kind of thing. I don't know. Not only like solving little subproblems, but also a map of how you're going to solve it as well on top of that.
Right, exactly. So that's exactly my point. It's not clear to me that the kind of chat API is really lends itself to this kind of problem solving. And sometimes it's even more than just that. Sometimes you would like to preserve some of the intermediate results that the model made. So, using the math example, perhaps it could have developed some nice theorems along the way that maybe could be even more useful than the actual Riemann hypothesis. So how do you somehow keep track of that knowledge, right? And obviously, in a chat API, that would be very annoying. Versus if it somehow started saving theorem somewhere, then this could, of course, be used for other people working on the problem.
Right. Okay. Let's take a step back. I feel like we're getting too much into way too far away from what's currently available, or even.
Yeah. Fair. Sure. I mean, that's fair.
Okay. So, but along this line, so what would be, in your opinion, like the next step? So suppose ChatGPT kind of did everything that we wanted it to do, or various other chatbot models. What would be the next step for you of a project? Like, suppose you were managing a team and you had your basically goal was to produce something interesting and valuable. What kind of things would you kind of explore?
Yeah, I mean, I think it's hard to say what the whole team should work on. I mean, I think we can take a look at what more the community is working on, and things that the community has found to be interesting. So, for example, one thing that is a bit limiting is that if you wanted to do something like prove the Riemann hypothesis, that would require a very long generation, right? Long, and it requires a lot of compute. So how do you actually get models to generate these long, do these long generations? How do you get them to actually invest more compute during inference than you would normally expect? So, for example, we saw before that using chain of thought or getting models to write out their thoughts actually led to better performance than just having the model spit out the answer. So how can we extend these ideas? So recently, there's been a lot of development, for example, trying to use different chatbots as agents to work collaboratively towards solving a problem, or perhaps having a model read its own solutions in many different ways in order to decide which one is the best solution. So this gives you a way of using the model beyond the way it was trained. So it's not just getting it to give you a question answer, but actually there's a whole process in generating the final answer. So I think what we'll see over the next few months, maybe a year, who knows, is that people will be investing more and more into what exactly the process of going from question to answer should look like given one of these models.
Okay, so you mentioned multi-agent, is that right?
Yeah. So
how does this work?
Right. So there was a recent paper that proposed something as follows. You can imagine you start with a model, and then you give it a question, and then it can provide you multiple answers. Maybe you sample different reasoning traces, and then you can
different
answers, different chains of thought. So it gives you uses different reasonings, it generates different answers, and then you make a different prompt that says, okay, pick one of the answers. Say, okay, all these other answers were solutions written by other models. So given those solutions and your solution, do you want to update your solution? And then the model can then take that into consideration and think whether it wants to rewrite the solution. So now you could do that with every single answer, right? And try to treat each answer as if it came from a different model. And then once you keep going, these things will actually converge. So they will, at some point, all the models will agree that, okay, this is the correct answer. And then you can take that as a final answer. Of course, if you have less models, then like the convergence time should probably be faster. But in general, I think empirically, we've seen that these things actually do converge fairly soon. So, and it does actually raise performance in a wide variety of tasks, ranging from factuality to reasoning tasks.
Interesting. So this is during training, right? You have different models that you're training simultaneously, or
no, this is
during inference.
During inference, yeah. So that you take copies of the model as different agents. I mean, of course, you could also just take different models, but I mean, for simplicity, it's just easier to take the same model.
And then you basically query the model many times and then take the most popular, or you gave a process actually that describes what you do.
Right, yeah. So the whole point is that you want to generate multiple answers, and then treat each answer as if it came from a different model. Have the model take the other answers as additional evidence or counter arguments to its own answers, and have it update its answer.
Mm-hmm.
Right.
Okay, so you're basically just automating the process of, basically querying the model, figuring out what's wrong with it, asking it if it's for sure, that kind of thing, or is question.
Right, exactly. But so this is sort of one step beyond that, in the perspective that it's not just like have the model give one answer and then have it correct itself. Here, it's like you're giving the model all the answers that it thinks are valid and having used all of this information.
And then it generates different answers because the process is stochastic, I guess, or random.
Well, right, exactly. Yes, obviously, there is some stochasticity in how we generate answers.
Recent paper. So that sounds pretty interesting. I thought that I've seen this before, like maybe even years ago, but maybe I'm missing something.
I think there have been variations on this idea. So people have done things like re-ranking, where you maybe create 10 different answers. You find some way of picking which is the best one. But I think this is getting closer to this idea of that, maybe we can, like, rather than just picking one answer, we can actually update. We can actually make a new answer based on all these answers. And the fact that we can actually keep iterating on this.
Or maybe it's important as well that you're like trying to question the actual logic or the reasoning.
Right, of course, yes.
Of the whole process, which is maybe something I hadn't seen before. But yeah, that's pretty interesting.
Yeah.
So basically your idea would be to try to improve I guess you're saying a big problem with the chatbot models right now is that they can actually be pretty wrong. And you're trying to hopefully improve that.
Right. I mean, and I think more than that is that they can be wrong, but they can also be correct. And sometimes you don't even need to train longer or anything. You can just use them in a different way from what you would normally expect to use them, and that can yield better answers or higher quality answers.
Right. Okay. So basically, improve the performance of the existing models through not through more training, but through more creative, basically prompt engineering, I guess, is the buzzword around that.
It's sort of. So I think prompt engineering is sort of still within its paradigm of you find some way to ask the question, and then you embed the question within syntax, right? Here it's more like we're actually leveraging the fact that the model is creating new knowledge in some sense. It's creating multiple solutions, and we're using that new knowledge to further incentivize the model to do different things.
I guess this kind of emulates how sometimes you might approach a problem in real life. You kind of
for sure
start off and you're like, oh, well, what if I started off doing this? And then you see kind of where that leads, and then maybe, oh no, that's not actually what I want.
For sure. You might even imagine this. Sometimes some of the intermediates that are created in wrong solutions could still be useful in some other correct solution. So maybe by giving the model access to those intermediates created in the solution that it itself created, then it could actually generate a correct solution.
Pretty interesting. Okay, yeah, I like that.
And I suspect that we'll also see not just like doing this through text, but also through other modalities, right? Like, for example, what if for a physics problem, it might be easier for the model to actually generate a drawing of the situation, and perhaps not all solutions will make a drawing, but once at least one of them has done a drawing, then the model in the next round can actually use that drawing to create a better solution.
Yeah, certainly incorporating other even images or would be useful, and these chat models, which of course is being tried, but it's all kind of active research, I guess.
Yeah, very, very early stages. But it does make you wonder, right? Like as humans, we reason through some things through more like there are certain types of reasoning that are more visual than say really expressed in text. And it could be interesting to wonder what kind of additional capabilities our models will have once they have this additional way of doing reasoning.
Yeah, here's a question, kind of related. So we've both done some, somewhat serious math in our lives. I was I don't know, I kind of of the opinion that a computer could probably eventually do math much better than I could. What do you think of? Do you think this is true, or do you kind of doubt it?
I mean, I would hope eventually they can. I guess there's a big question of like, what does it mean to do math better, right? Like obviously, like, is it just the art of proving theorems? Is the art of creating theorems? There is a certain element of aesthetics, and obviously we've seen that, like, for say creative writing or images or paintings, models have been pretty good at capturing that level of aesthetics. So maybe the same thing is true for text or for math. I don't know. But I think for sure theorem proving should be hopefully easier for computers. Eventually, I think perhaps maybe we'll run into an issue of like, how do we check correctness? How do we actually, even for humans, it can take us like months to verify the correctness of a proof. And so I imagine as a proof complicated, perhaps more foreign looking from these models, that maybe it might take us longer to actually verify correctness.
Okay, just a quick aside. Anyway, so back to normal, generative AI things.
I mean, I do want to say that I think it is an important issue that we will keep wrestling, right? As we get superhuman models that are able to create superhuman content, right? How do we ensure that this content is so useful for us humans, right?
What was I going to say? So I think an important part of the process is the data, I guess. Maybe you have some insights into what's going on in terms of quality of data and these large language models, maybe even some of the history, because even going back a bit.
Yeah, so this whole issue of data quality has been kind of like a mixed thing. So I think in the past, some people thought that it didn't really matter. Oh, we just train a big model; it would just see everything. We have so much data. I think over recent years, we've seen that this is kind of the wrong way of thinking about things, and that data quality actually heavily matters. But as to what is the best way of measuring quality, I think that's still very much an open problem. Obviously, people have developed certain hints and tricks. So I think, for example, DeepMind's Gopher paper, they shared some of their filters for what they use to like select data from the internet. But in general, this is quite hard, especially.
Sorry, what did you say about the Gopher paper?
So I mean, obviously the internet has like almost infinite data, but like a lot of that is garbage. So you have to somehow extract the valuable data. So I think in the Gopher paper, they actually released some of their filters. They said what they used to remove data or to keep data.
Do you remember one interesting one, maybe? One interesting filter, that is?
I think a lot of them are, I mean, I don't know if I would call them interesting. I think a lot of it is more like heuristics, things like, oh, if it's longer than this or shorter than this, do this. Or if it contains this kind of information, do this. Or maybe sometimes people use things like blacklists. So if there's any of these words, remove them. And so I think these things can be pretty good for English. But once you go beyond English, so either multilingual or code, then some of these tricks get harder to apply. And it seems like every domain will start requiring new and more tricks. And then once we go to multimodal, so like images, audio, you start running into the same issues, like how do you measure quality for these new domains? So I'm hoping that we'll see more of this coming, but I think the people that have the power to build these pipelines are also not heavily incentivized to share their tricks. So it's not clear if we'll see so much of that in the literature.
You're kind of saying it's an important part it's almost like part of the creative process of building these models, right? Is basically figuring out how you're going to actually filter or even get your data, and what data are you going to use, and all these questions are kind of
100%, yes. And I think it's sort of like not like at face value, it doesn't seem that interesting, right? Like when you think large language models, you're thinking all the large parameter count, there's some exotic architecture. You're not thinking like, oh, is this website actually good or not? But it's sort of actually very fundamental and important part that very often gets left out of the discussions from both people and also in the papers themselves.
I feel like it's pretty interesting. He said it's not really the most interesting, but I feel like if you asked maybe a non-ML person, that would be like the first thing they would actually probably ask about.
So that's true. That's true. I guess I meant more in the ML community.
Right, in the ML community, it's like, oh, what's the architecture? How are these things trained? You know, because there's so much interest in, you know, engineering and mathematics and all that goes into
it. Exactly. Yes.
Whereas, you know, cleaning data is not really the sexy part of being a machine learning engineer or data scientist.
Yeah, well, I mean, I think data scientists in general do appreciate the value of data cleaning. It's like sort of part of the culture. But I think within ML research, it has somehow it had fallen out of favor, and I think now it's becoming more, or people are realizing how important this is.
That could be partly just because seems like the model architectures basically are kind of decided what people are going to use to train these LLMs. Is that kind of fair or not really?
No, I mean, obviously, I think improving architectures is, of course, useful. But I do think, like, even if you have a better architecture, if your data is bad, then the model will be bad, right? Like, obviously, we all have also developed ways to sort of correct this. So things like instruction tuning or reinforcement learning via human feedback sort of helps you along these ways. But that sort of obfuscates the need for high quality data more so than get rid of it.
So how do we see this going forward? So basically, it's not surprising. So LLMs basically was make them bigger, right? For a while, and then alignment was part of the recent progress, I guess.
For sure.
And then, would you say improving data might be something that would be one of the avenues that might lead to the most progress in terms of, I guess, value of these things?
For sure. And I think because it's not just improving data, but also like getting more high quality data. So like we already have access to there are public data sets, for example, that are pretty high quality but very small, and the ones that are really big are like also with garbage. So I think being able to assess how much data is actually useful or valuable, and if there's not that much, how much can we add garbage or not pure garbage, but maybe not as valuable, and correct that using alignment, some other techniques. Because like even like bad data, like as long as it's not complete garbage, there's some value, right? There's some content. So it might just not be the most valuable piece of data compared to, like, I don't know, something extremely high quality like Wikipedia. And so trying to figure out what
Wait, Wikipedia? Did you say Wikipedia extremely high quality?
Yeah, I mean it looks high quality, right? It's like
people would disagree.
Perhaps, but like I think it's better than just like random forums, right? So you go to some random website, you'd be like, oh, what is this, right? At least Wikipedia has like content about many different areas of science and history and blah blah blah.
Yeah, I like Wikipedia for like factual things like math or science.
So yeah.
Do you see a world where experts are getting paid to just like produce data for these models?
So I don't know about produce data. Like I think they're just somewhere writing data that we use for training data. But I do see a world where they might interact with models to try to like create new data, like to create something better than either the model or the expert could do, and try to use that to augment the model's data.
Oh, I see. More along the lines of the reinforcement learning from human feedback.
Yeah, for example, something along those lines. Or so to give an example, when we do math, right, we write it down a proof, but the proof doesn't really capture all the steps that we took to come to the proof, right? And no one really writes those steps down. So there's this data that's missing. You might imagine that if we were able to write down all the thoughts that came into mathematicians as they were doing work, write down those intermediate steps, that might be useful for training models to do math.
I would argue those steps are written down. It's just, I mean, okay, for maybe like research that was produced in the past decade, maybe not, but for math that was discovered like 150 years ago, someone's written down like all the intuition and all the steps that were taken to prove something.
It's sure, but we're trying to do research, like do cutting edge research, right? Not do research on stuff that was 100 years old. I think it's more like being able to, like, this idea of like actually doing research rather than just seeing the final product. It's just not clear. Like how many failed proof attempts did you have to do to prove something? And I think maybe one might argue that those were actually necessary. We needed to fail. We needed those intermediate results, intermediate knowledge gained from those failed attempts in order to prove the final theorem. And if the models don't have access to that exploration set, then how could they themselves prove theorem?
Yeah, I guess the models don't appreciate how valuable of a lesson failure can be, huh?
Yeah, exactly. Which is also why I find very interesting this whole idea of like multi-agent debate, or like getting multiple answers and passing that to the model, because it gives the model some way of exploring, of trying things out, and learning from those attempts. So I think if we had more of that, but done by actual humans, and capture this entire trajectory, then it might be very, very useful data.
All right, let's call it here on the discussion. I guess let's end off on this easy question. So if you hadn't studied AI or machine learning and you were interested in it, what advice would you give to yourself to now that you are doing work in it, to basically become active in the research community?
Yeah, so I think for sure the most important thing to do is to try to get involved in open source projects. So in my personal experience, I've seen lots of beginners have extreme success joining ongoing open source efforts through programs like MLC or Luther AI. They've been able to actually join projects and learn, like receive mentorship and guidance from the project leads. It helps you. It has helped them build their resume, as well as establish a community for them to learn more, to learn more about what's currently going on, as well as like what kind of knowledge is needed to progress in this field. Like, I think it's far better use of their time than, say, reading some book by yourself. It's really important to like talk to people and get involved as soon as possible.
What if someone's kind of like not having that much experience and they're a little bit timid to join the community or ask questions?
Yeah, so I think these communities are also not just purely about machine learning or AI. I think a lot of it is also a social aspect. So I don't think the kind of commitment that one person might have could be very different from the kind of commitment that another person might have. So I think like it is like anyone can join. Well, for some of these communities, it can be that anyone can join. Of course, like if you don't know basic math, obviously you should take the preliminary courses and get the required background just to be able to have conversations. But beyond that, I think people tend to overestimate how much background they need to really get going, when a lot of this you can just pick up by working on a project with someone.
All right, fair enough. Thanks for joining, and yeah, we'll talk again sometime.
Looking forward to it.